Hi students, welcome to the next class. In this class, we will discuss about torque acting on current carrying conductor or loop in uniform magnetic field. In uniform magnetic field, we are going to place one current carrying coil. How torque is going to act on this? So before going to this, already we came to know torque acting on the electric dipole in uniform electric field. So there what we got? P bar cross E bar in electric charges and fields. Now tau is equal to PE sin theta. Did you remember? What is P means? Electric dipole moment. What is E means? Electric field intensity. Same like that. If you are placing current carrying loop, just I am placing like this. This is A, B, C, D. If current is passing like this, A to B, B to C, C to D, D to A. So this is length, breadth. Now, whenever current carrying loop is placed in uniform magnetic field, so uniform magnetic field I am taking like this. So simply I placed perpendicular to understand easily, isn't it? Now what is the force acting on AB? Force acting on AB because this AB is perpendicular to magnetic field. So what is the force acting on current carrying conductor formula? BIL sin theta. Here length is perpendicular to B, therefore sin 90 B I, length of this conductor is L. This is the force. What is its direction? We will see the direction later. This is force on AB. What is the force on BC? Force on BC. So this length is parallel to B is parallel to B. Therefore, BIB sin 0. Therefore, there is no force on BC. Same like that, there is no force on AD also. Here, AD means sin 180. BIB sin 180. Current is coming like this in the direction of B. B is opposite. Therefore, these two will be 0. Force is 0. Now, what is the force acting on CD? CD is equal to BIL sin 90. That is also BIL. How this force is acting? Direction. Direction, if you want, in two ways we can calculate. One is by using Fleming's left hand rule. Here current is going downwards. Magnetic field is right side. So forefinger represents field, thumb represents current. Now, sorry, center finger represents current, forefinger represents field, thumb represents direction of the force. So it is coming outside. Force is coming away from the board. Same like that on this, force is going into the board. One is outside, one is inside. Therefore, resultant it is going to be turning like this. So if this is the loop means one force is outside, one force is inside. Therefore, resultant outside and inside it will be rotating like this. Therefore, we will say torque is acting. Otherwise, to get the direction, we will use this formula also. F bar is equal to IL bar cross B bar. IL bar, this length is downwards. I is coming downwards. Therefore, plus J cap. Correct? Sorry, minus J cap. Because downwards, upwards means plus. Minus J cap. B bar is right side, I cap. Then how it will be coming? IJ, JK, KI. So this is JI. So IJ means I cap cross J cap is equal to K cap. Now J cap cross I cap is minus K cap. So minus K cap into minus, that is nothing but plus K cap. Therefore, force is outside. Now on this, if you want to calculate force, this force is on CD. Now force on AB. So IL, this is going to be upwards in place of IL plus J cap. Magnetic field is same. So J cap plus I cap is minus K cap. Therefore, one force is outside, one force is inside. So resultant it is turning like this. Now turning effect produced by single force, force into perpendicular distance. So what is that perpendicular distance means? One force is upwards, one force is inside. So between these two, what is the perpendicular distance means? B. Now what is F? BIL. So BIL into B. Length into breadth. Area we will say. BIA. I into A. That is only MB. So here we have taken perpendicular, therefore you need to get sin theta 10. If this loop is making some angle, then you will get theta. Therefore, finally they will write tac tau is equal to m bar cross b bar. If you compare with this equation, in place of E bar electric field, you will get magnetic field. In place of P bar, you will get magnetic field. Whenever this coil is making angle theta, here in place of B, you will get B sin theta. So the derivation is not required for competitive. So just by comparing this, we can remember. But why I said means, so sometimes they may ask question on only this force acting on only one wire within this loop. At that time, it will be helpful, including direction. So tau bar is equal to m bar cross b bar. This tau only we will write mb sin theta. When the torque will be maximum, same like this. Torque will be maximum if theta is 90. Maximum torque is mb. When torque will be 0 means mb sin 0. So angle between m and b is 0 means in the direction of magnetic field, the direction of the magnetic moment is also there, then it is going to be 0. Opposite also it is going to be 0. If this is the loop, let us assume current is passing clockwise here. Whenever current is passing clockwise, magnetic moment is into the board. Field is like this. Therefore, angle is 90 maximum torque. If you place loop like this, current carrying loop, so loop is going to be clockwise, current is going. Then magnetic moment is left side. Here magnetic field is right side. At that time, 0. Sin 180 is going to be 0. Isn't it? Perpendicular to loop, parallel to means perpendicular to its direction of the magnetic field, parallel to direction of the magnetic field. So that one you should see very carefully. Here loop is parallel. Loop is parallel means you should not take theta as 0. Loop is parallel means its magnetic moment is perpendicular. Therefore, theta you should take 90 for this. So that should be very careful. So they are giving angle with the loop or angle with the direction of the magnetic moment. But here we have to take direction of the magnetic moment. So plane angle we should not consider. There and here also. There dipole is making some angle. Here magnetic dipole moment is making some angle. So this is the torque acting on the magnetic dipole moment in uniform magnetic field. Next, moving coil galvanometer, MCG. So in this coil, whichever we have taken, this current carrying coil, we are placing in strong magnetic field, radial magnetic field. So radial magnetic field between two horseshoe magnet. So always magnetic field direction is perpendicular to the direction of the loop. At the time, whenever we are placing magnetic field, current carrying loop within that magnetic field, torque is going to act. Tau is equal to, what is our formula? MB sin theta. If it is having magnetic moment, one loop, we will take M is equal to IA. For n loops, we are going to take NIA. So therefore, whether one loop or n number of loops, you can consider if it is n number of loops, NIA-B, this theta, always magnetic field produced by this horseshoe magnet and this magnetic moment direction will be always perpendicular. Therefore, we will use radial magnetic field. So maximum torque is NIAB. This is going to be suspended by phosphor bronze wire. So we will take here one mirror, whether it is rotating or not. Whenever coil is rotating, this mirror will be showing deflection like this. Whenever it is showing deflection, so within this one twist is going to be happen. So if you are taking one object like this with a rope or thread, if you rotate one rotation clockwise, so one twist is going to happen within the string. If you make two rotations, two twists will be coming. So if you leave this, it will be rotating backside. Why? Because within this restoring torque is going to happen. So within the spring, how restoring force will act to pull the object in opposite direction. Same like that within this rope, what is going to happen means restoring torque is going to be developed. So that will be developed due to the torque produced within this rope. This restoring torque, what it will do means again it will rotate in opposite direction. So the restoring torque per unit twist is nothing but C, they will call. So this restoring torque is going to be C theta, they are going to write. This restoring torque should be equal to this original torque, that is going to be NIAB. This one only they are going to write theta is equal to NAB by C into I. Then theta is directly proportional to I. This constant NAB by C, we are going to call it as constant. So always deflection is directly proportional to the current. So the amount of deflection per unit current, the amount of deflection per unit current, we are calling it as NAB by C, isn't it? So large deflection for small amount of current. If it is making large deflection for small amount of current, that is only current sensitivity. Current sensitivity. So generally common word they are going to use. What is sensitive means? So if you are scolding, they may cry. Those are sensitive, sensitive instruments, sensitive people, sensitive persons we are going to call. So sensitive means, so if you are scolding them, they are going to cry. For lesser scolding only, if you shout on them, they are going to cry. Same like that. If you send a small amount of current, it will going to show large deflection. That is nothing but current sensitivity. So current sensitivity is depending on number of turns, area of the coil, magnetic field intensity, and the C. C is nothing but restoring torque per unit twist. Next, voltage sensitivity. Voltage sensitivity. This is going to be Vs they will represent. What is Vs means? So large deflection for small amount of current. So here large deflection for small amount of voltage we will call. So theta by V. According to Ohm's law, V can be written as IR. Again theta by I. We can write current sensitivity. Is by R. Again what is Is? NAB by C. Therefore NAB by CR. Extra R will be coming. If R is coming, that is voltage sensitivity. Now see the relation between voltage sensitivity and current sensitivity. Vs equal to Is by R. You should be very careful. According to Ohm's law, V is equal to IR. But according to sensitivity, whenever it is coming, Vs equal to Is by R. Vs equal to Is by R. So you will get resistance if you know current sensitivity and voltage sensitivity. So they will give graph between Is and Vs. They will give graph between Vs and Is. So Is means current sensitivity, Vs means voltage sensitivity. So if you got graph, what is the slope of this graph is going to give? M. Slope of Is Vs graph is Is by Vs. Slope of Vs Is graph is Vs by Is, y axis by x axis. So Is by Vs we came to know. Is by Vs we came to know, that is resistance. So slope of Is Vs graph gives resistance of this coil. So this is about current sensitivity. This is about voltage sensitivity. To increase the voltage sensitivity, N should be increased, area and the magnetic field should be increased. C and R should be decreased. So if you remember formula, you are going to get all this. Now how we will convert this moving coil galvanometer into voltmeter, ammeter? That one, why we have to convert, that one we will discuss in our next class. Now in this you should be thorough with current sensitivity, voltage sensitivity relation and torque acting on the current carrying loop in magnetic.